Hi there, it's Mrs. Lindquist. So let's continue on here. So what is a periodic function? A periodic function repeats a pattern of y values at regular intervals. So then what is a cycle? A cycle is one complete pattern. So let's talk about the period of a cycle. The period of the cycle is the horizontal length of a cycle. So you can think of period as being x, and it kind of measures the horizontal length. So I drew a horizontal line there. So you can begin at any point on your graph and trace a complete pattern. So if I go from here to this green dot, this is a complete pattern. It makes the V shape, and then it makes the V shape again, and it repeats. So what is the length, this horizontal length of this pattern? Well, the pattern starts at 2 and it ends at an x value of 6. So my period would then be, if I just take 6 and subtract the 2, my period is going to be length 4. So what happens if I started my cycle here at 0 and then go ahead and go up and down and back to 0 again? That's a complete cycle. I can see it will repeat again here, 0, up, down to a min, and back to a 0. So this cycle goes from 8 to 12. Again, if I do 12 minus 8, I'm still going to get a period of 4. It still has the same horizontal length. For each function, identify one cycle in two different ways, then determine the period of the function. So we can see what I've highlighted here is one complete cycle of this curve. It's kind of a hill and a valley, and then that repeats. You can see I have another repetition here, a hill and a valley. So we can do one pattern from x equals 0 to x equals 4. So from 0 to 4 would be a complete cycle. What would be another way to identify a cycle? Well, we could go from a minimum to a minimum. So that we could just do one big hill, and then we could do another big hill. So that would be from -1 to 3. So that's two ways of defining this cycle. Likewise, we could go from a max to a max. So we could go from -3 to 1. So how do we get our period? We just want to find the horizontal length of this cycle. So 0 to 4 is probably the easiest. 4 minus 0 gives us a horizontal length of 4. We can also get it by subtracting these other ones. We could also have done 3 minus -1, and that would have given us 4 as well. So I want you to pause this video and I want you to try this problem. See if you can define a complete cycle or period of this function and then figure out what the period is. So go ahead and pause it and then we'll come back and talk about it. Okay. Did you do it one of these two ways? I find a lot of students come up with these ways of defining a period. So we can go from a max to a max. So that would be like this V shape that keeps repeating itself over and over again. So basically from 0 to 3. So 0 to 3 would be one way to define the cycle. Or maybe you saw it as like this hill that kept repeating itself over and over again. So that would be from -4 all the way to -1. So that's two ways you could define this cycle. So let's take a look at what the period of the cycle would be. So remember, the period is the horizontal length of the cycle. So the easiest way would be to just do 3 minus 0. But likewise, if we did -1 minus -4, we are also going to get 3 for our period. So let's take a look at this section. It says, is the function periodic? So remember, the definition of periodic means the pattern of y values repeats at regular intervals. Determine whether the function is or is not periodic. If it is, find the period. So do you think that this function is periodic? I found a pattern and I see that the pattern is repeating itself, but does that make it periodic? If you said no, you'd be correct, because remember, it has to be the same pattern of y values at regular intervals. So what we see here is that our y value starts at -3, and then the pattern ends at -2, and for the next cycle I start at -2 and my y value ends at -1. So the y values are just increasing. So this would not be periodic. So I would say something like the y values increase, not repeating. So in this case here, I would say that this function is not periodic. So take a look at the second graph. Pause the video and see if you can figure out if this example is periodic or not. So when I look at this graph, if I start here, I can see I reach another max here. So is this the complete pattern where it kind of goes down, there's this little wave, and then comes back up? If I look over here, it looks like the same pattern is going to repeat again over this way. So the same pattern of y values. It starts at 2, and then it goes down to 0, down to -3, and then back up to 2 again. So the y values repeat at regular intervals. So I would say, yes, this is periodic. What is the period of this particular function? If we start it here at 0, it's going to end at, oh, wait a minute, looks like the intervals are not going by ones. They're actually going by intervals of 2. So 2, 4, 6, 8. This would actually be 10. So my period is going to be 10 minus 0, which is just 10. That is the horizontal length of my cycle. Okay, the last thing we're going to talk about is the concept of amplitude. Amplitude is half the difference between the maximum and minimum y values. So when you think of period and you think about it measuring the horizontal length of the cycle, amplitude actually measures the vertical, but it's not the full length of the vertical, it's only half of the difference. So let's take a look at this particular cycle. Let's highlight one interval here so we can kind of see what is going on here. So if we wanted to know the period, we would go from maybe like a minimum to a minimum. The period is going to be what, 6? But when we're talking about amplitude, it's half the distance between the maximum and the minimum. So what is the highest this thing goes? The highest point is 3. The lowest is -1. So my amplitude is going to be max minus min. That's the difference between the maximum and the minimum values, and we're going to divide that in half. So divide by 2. So in this case, we're going to have 3 minus -1 divide by 2, which is 4 divided by 2. So my amplitude is 2. When we get into sine and cosine waves, we're going to kind of be looking at this midline of the graph. If you were to draw a dashed line through the middle of the graph, and what the amplitude is going to represent is going to be the height of the peaks. So to go from the top, from the midline to the maximum, that's going to be a distance of 2. Or if you go below the midline of the graph, that is also going to be a distance of 2. So it's really going to, when we start doing sine and cosine waves, it's really going to be important to know the amplitude of the peaks. Okay, so in this example, we're putting it all together. Find the amplitude and the period of each periodic function. So again, when they say it's periodic, they're already telling you that the y values do repeat. So let's find one cycle of this. Maybe the cycle you're seeing starts at 0 and does a little valley and then a big valley. That would be one complete cycle, and then it repeats, does another little valley and another big valley. Or maybe you see the M, which goes from a minimum to a minimum. In either case, let's take a look at the period. The period is the horizontal distance of the cycle. So the period would be from here to here. So my period, in this case, is going to be 3 minus 0, or just 3. So now let's talk about the amplitude. So the amplitude is the maximum minus the minimum divided by 2. So our maximum this thing goes to is 0. So that's the highest. Minus the minimum is -4. So 0 minus -4. And then we have to divide that difference by 2. So we're going to end up with 4 divided by 2 is 2. So my amplitude is 2. So if you think about it, if you drew a dashed line through the middle of this graph, the heights of these peaks are going to be 2. So you could go up 2 that way, or if you go from the midline down, that would be 2 as well. So it kind of indicates how tall the peaks are. I want you to go and look at this last example here, and then we'll talk about a story problem and wrap it up. All right, when I looked at this particular problem, I went from a maximum to a maximum, so kind of like this valley that keeps repeating. It's possible that maybe you looked at the hill. Maybe you started at 1 and you went to 3. In either case, let's take a look at the period of this. So for my particular example, I would be going from 0 to 2. So again, you can't just count boxes here. You actually have to look at the units. If I didn't look at these intervals, I might have said 1, 2, 3, 4 boxes. My period is 4. When indeed it is actually 2, because it goes from 0 to 2. So 2 minus 0 gives me a period of 2. The horizontal length is 2 for this particular wave. So now let's look at the amplitude. The highest y value on the graph, again, I have to look at my units. This is not actually 1. They're scaling by 2, because if that is 4, then this must be 2. So the highest it goes is 2, minus the lowest is -4. 2 minus -4, and we have to divide that in half. So 6 divided by 2 is 3. So again, if you were to draw a dashed line through the middle of your graph, like that, you can see from that line, you're either going up 3 or down 3. Okay, so let's take a look at our last example. Okay, so to wrap up, we're going to take a look at this application problem. The oscilloscope screen below shows the graph of the alternating current electricity S in volts supplied to homes in the United States. Find the period and the amplitude. So you can see here, they already actually highlighted a cycle for us. So if we start at 0, where would the cycle end? So it looks right here, it's going to be 6. So you might be tempted to say that your period is 6. But is it really 6? And what is 6? So the units on this is t, and it says here 1 unit on the t-axis is 1/360th of a second. So 6 does not mean 6 seconds, because each unit is only 1/360th of a second. So we're going to do 6 times 1/360. That is going to give me 6/360ths, and we can reduce that. So the period is actually going to become 1/60th of a second. That is one complete current wave, so not 6 seconds. The last part is the amplitude. So amplitude, See if you can figure that out. So go ahead and pause the video and calculate the amplitude. So if you got 120 for your amplitude, you'd be correct. The highest that this wave goes is 120 volts, and the lowest is going to be a negative 120 volts. And we're going to divide that by 2. So basically 240 divided by 2 is going to be back to 120. So it's 120 volts. So again, if you drew that little midline through the middle of your graph, you can see that either from the midline you're going up 120 volts or you're going into the negatives 120 volts from the middle of the graph. Okay, that's a wrap. Talk to you guys later. Bye.